All right, all right. So in chapter 2, we're going to be talking about equations, which basically is the next step in our composition of mathematics. So in chapter 1, we learned that expressions are made up of terms and terms are made up of factors. So all we did in chapter 1 was just talk about the composition of expressions. So now an equation is how we can look at expression values. So equations are made up of two expressions and is used to compare the equality of the expression values. So we use an equal sign between two expressions to compare their values. Well, a lot of times this might be misleading because just because there's an equal sign doesn't mean that the equation is true. An equation is true if both expression values are the same. So we might see something like negative 3 or the opposite of 3 squared equals, and then in parentheses, negative 3 squared. And we looked at this before. We realize now that since the equal sign is outside of the factor operator, this is like a factor of negative 1 and a factor of 3 squared, which is positive 9. So the expression value is negative 9 on the left side. On the right side, because of the parentheses, we realize this is two factors of negative 3. And when we multiply those together, we get positive 9. So in this instance, the values of the expressions are not the same. So this equation is false. A lot of times when you have a false equation, you might see a slash through the equal sign to show that it's false. So back up here, we know we could put a slash through that to show that it's false or that they're not equal. An example, if I'm looking at two expressions, say I got one expression, which is in parentheses 7 and negative 4 squared, and then is that equal to the absolute value of negative 2 plus 7? So you'd have to find the value of each expression. So on the right, I have a factor that's squared. That factor is 7 and negative 4, so inside is a 3. And if I take 3 squared, I get an expression value of 9, positive 9. On the right side, I have two terms. The first term is the absolute value of negative 2, with it, which is positive 2. And then I have a positive 7. And if I combine those two terms together, I get an expression value of positive 9. So this equation is actually true. And I just want us to realize that an equation is made up of expressions, so it's our next level of composition. And an equation needs to be kind of justified whether it's true or not. So in section 2.1, we want to talk about solving an equation. A solution to a variable equation is a value for the variable that makes the equation true. So if we have a variable equation, 3x minus 5 equals 5x minus 4, I get two variable expressions. And in order to compare their values, I'm going to substitute into the expressions x equaling negative 2. So I want to use the equal sign, and then in the left, I want to evaluate 3x minus 5, which is two terms. And I'm just going to substitute the factors in the left, or 3x is the factor of 3, and then x is a factor of negative 2. So the term value for 3x would be negative 6, and then I got negative 5. When I put these together, I get an expression value of negative 11. So I'm going to see what that, if that is equal to, so it's kind of like a question mark here. If I plug in on the right side, I have two terms. 5x has factors of 5, and then the factor of x, which is -2. The other term is -4. So I get 5 times -2, which is -10, and -4. And if I combine those together, the value of the expression on the right is -14. So we found out that the two expression values are not the same. It gives a false equation. So therefore, we say that x equaling -2 is not a solution. So how do we actually find solutions? So one of the ways we can find solutions, and that's really what the goal is when we have a variable equation, how do we actually find solutions? So to solve an equation, we want to find all values for the variable that makes the equation true. It's as simple as that. So if we want to solve the following equations by translating, basically just understanding what the equation is saying. If we translate this equation, we notice the left side is an expression, and if we translate that expression, we might be able to say it is, 3 less than a number, right? And the equal sign, when we translate the equal sign, we can say that it's the same as is, and then the right side of my expression, or the right side of the equation, is 7. So 3 less than a number is 7. And we can think of it as a way of asking a question. If I take 3 less than a number and the answer is 7, what would be the number? And so the solution is, or the number is, must be 10, right? Because 3 less than 10 is 7. And that's just by understanding what the question is asking and then kind of guessing. So the number must be 10. We could think of this then as an equation. X is the number, and it must be 10, equals 10. And this is a way we can write solutions in algebra. Just x equals, it's like a statement of the actual solution. So let's do this next one. The left side of the equation translates to a number divided by 3, and then equals, the equal sign could be the same as, or gives even, a value of 4. The right side is a value of 4. And the only reason I'm writing this a little different is because there's so many different ways to translate algebra to English. There's a lot of different ways to do that. So what number do we divide 3 by? Or what number do we divide by 3 and get 4 for an answer? And if I take 12 and divide it by 3, the number must be 12, right? So x equals 12 would be a way in algebra that we represent that answer. So if we understand the question, we really don't have to do algebra. But in the next section, what if the equations are not easy to solve by translating or even guessing? What do I do then?